Welcome to today's section. In this section, we're going to look about tips to produce a successful plastic component. And I am Gautam Srinivas, Elite Application Engineer, taking care of solution products at EGS Computers India Private Limited. Let's look upon the topics we're going to discuss in this section, starting with historical process to build a plastic part and what are the defects we will face in a plastic injection molding, then various ways to fix a problem, then let intro to sawdust plastics, then challenges in injection molding, and we go through a live demo. Then let me share a few case studies, then our product capability and few customer references. At the end, we're going to have our question and answer section. Let's go through our first topic, historical plastic development process. First of all, what we will do, we will design our part. Then we will do the mold tool design. After the both were done, we will build our mold tool. We will manufacture the mold tool. And we do the injection molding of our plastic part. Once the production is done, we will launch our product to the market. It is easy to produce a plastic part without any defects. No, we need to go through and cross various defects, starting with burn marks, weld lines, shrink mark, air traps, void, flash, short, and warpage. We need to come across all those defects to produce a successful plastic compound. Let's see the traditional way or a old type of way to fix this problem. We will do the plastic part design, then the mold design, then we'll build our mold and we'll go with the production. After the first components get produced, if we face any plastic defects, what we will do, we will go with the in-depth simulation. So in this type of fixing a problem, it involves a huge cost and it is ineffective too. Let's think, what if you have a design stage before building a mold? Yeah, it will avoid the plastic for defects after manufacturing, but also it involves a hidden cost like the time taken for plastic part design and the mold design. So it does also stop us to deliver part in time. Let's think about what if we have a simulation stage in design stage itself and the mold design stage itself. So in early design stage itself, we can avoid all those defects and produce a first component as a successful component. So it will be an optimized way of manufacturing a plastic part. When we compare with the impact and the cost of a change, if you do any changes in part design change itself, it won't involve a huge cost. If you find out any defects and if you plan for any redesign or rework after the product launch, it involves a huge cost. Let's see how sawdust plastics help us to overcome these challenges. It can predict and avoid the manufacturing defects in design stage itself. By that we can eliminate the cost of the rework and we can improve the part quality and we can decrease the time to market. If you look upon the value proportion, more than 80% of plastic parts injection molded. This injection molding is a complex mixture of time, temperature, pressure, material and tool variables. For each mold design, it involves a cost of $10,000 to more than $1 million. So if there is any rework, it is very costly and time consuming too. So by this we can achieve the return of investment in a very short span of time. Let us discuss about the various challenges faced by various group of people. If the part designer, they need to ensure whether their part is get filled or salt and where the well line will occur, whether they need to avoid the well lines in load acting zones and they need to avoid the air traps to reduce the burn mark issues. If there is a mold maker, they need to optimize their multi-cavity mold and they need to have a balanced runner for multi-cavity and they need to find out how much pressure is required to do fill this cavity and by filling this cavity whether what type of machine they need to choose and if there is any senior engineer or a CA analysis they need to find out to produce a best cooling design to produce a optimized heat transfer efforts and they need to avoid the part warpage to avoid the fitting issues, and they need to minimize the cycling time to reduce this plastic part to increase the productivity. We're going to share a roadmap to do those activities. We will design a plastic part component and we will do an in-depth analysis of this plastic injection molding through sawdust plastics, and we look upon how we can ensure the product stiffness and we can estimate the life of the product and how we can share these data with our customer to impress them, and finally how to document all those activity. Let's look over this in a virtual demo. We had done the plastic part design in our Sawdust 3D CAD. Once the design is done, we can go with the Sawdust plastics which comes as an add-on to our Sawdust 3D CAD. Once these Sawdust plastics get added on, what we can do, we can set up the entire scenario, starting with saying how the mold box and the cooling channels get built. For this, we don't need any 3D data. Only thing we need is the layout sketch for the cooling channel. Once we design the layout of the cooling channel, we can directly select those sketches as a cooling channel. So software will recognize those path and we need to say the diameter of the cooling channel, and this thing can be assigned. Once the cooling channel is get assigned, what we can do, we can compute and we can virtually generate these cooling channels. Next thing we need to say about the mold box. This mold box can be added virtually, no 3D CAD geometry is required. Software has the intelligence to predict the bounding mass of the cavity. Then this model need to be splitted into finite elements to convert this 3D geometry into a mathematical model. For that, we can make use of software intelligence. So software can choose a better type of element and sizing rate to build an high accurate results. So sawdust plastics comes with various element types, starting with tetrahedral or a prism element. Various of elements software can be chosen automatically, or we can manually choose those elements and build a better high quality mathematical design. Once all those things is get done, and now we need to say the other conditions like machine parameters and where the gate is get located. Okay. Now we look upon how we can set up the material for this model. So first we're going to choose the material. For this we can make use of a material database which is available in Sawdust Plastics. We have above 4,500 variant of plastic material with all the predefined material properties like glass temperature, well temperature, all those things. Then coolant also we can choose various type of coolants like water, oil, or any other chemicals. And mold box, how it is made up of, whether it's steel, copper, or aluminum, and all those metal properties are predefined. Next, we're going to say about the machine setup. Let's see about the fill settings, what the maximum injection pressure limit of my machine, and what is the flow rate of my machine. And we can set up the flow rate of our machine. Then we say about the packing settings, how long the packing stage need to be there, and we going to say about the warpage, what the ambient temperature and how my components get oriented. And in the cooling settings, we can say the temperature of the inlet coolant. Next, we set up the gate location. For this gate location, software has intelligence to automated selecting the gate, or else we can manually select those gate and we can say the size of the gate. Okay, once all the setup is done, we can calculate the results at each stages called cool, flow, pack, and warp. Once all the studies get calculated, we look upon the flow results. First plot result says how long time the it's taken to fill this cavity, and we can virtually animate and see how the molten polymer is fill this cavity and how much time is required. It's around 2 seconds. And we can also look upon where the well line is occurred and profile of the well line. If the well line has occurred any load acting zone, then we need to choose the better gate locations or we need to redesign. And we can also view about the add traps. So if there is plenty of add traps, we need to plan for the vent analysis to avoid the burn mark issue. Next, like we look about the how much pressure is required to fill this cavity. It's up around 61 megapascal. So it is on quite short pressure only because my machine pressure limit is around 100 megapascal. So it is easy to fill this cavity. We can look about this plot called easy to fill plot. So entire cavity is shown in the green zone. So green zone shows it is very easy to fill. Okay, what if we have a short tissue? That region is shown as a red color zone. So red color zone will be the short region, which is a warning zone. Let's look upon the pack stage results. The pressure holding is around 24 megapascal and the volumetric shrinkage after the packing stage is around 5%. Let's look upon the cooling stage. The maximum cooling time is required is around 14 seconds and the heat flux is around 4.4 joule per centimeter square. And the heat load is 86 and the temperature of mold is around 63 and the temperature at the end of cooling is around 75 degrees Celsius. And when we look upon the warp stage, we can see how much displacement is happened after the warp stage is around 1 mm. And in this stage also, we can virtually see how the components get warped. And we can say whether it is within the limit or it adjusts the limit. So we need to plan for any mission settings or any redesign. So we can virtually see how the components get constrained. And additional to that, we can also view in each axis in what the displacement happened in x direction or in y direction. So let us have a close look about the warpage happen in x direction. So maximum warpage happens around 0.3 mm in x direction. That too can be virtually animate and see, so that we have a better clarity whether the mounting part will be get fitting issues due to this much displacement. Addition to that, we can look about the residual stress displacement. The residual stress displacement happens around 0.1 mm. And we can also see about the residual wall measure stresses around 21 megapascal and the demold residual wall measure stresses around 27 megapascal. Okay, we got all those results. So now I need to export these results to simulation to validate the stiffness of my product. For that, what we can do, we can make use of the export option in Sawdust Plastics. So these all the residual stress can be exported to Sawdust simulation or any other analysis solvers called Abacus or a sort of simulation, and what type of results need to be exported. And once the exporters get done, what we can do, we can import all those stress results into sort of simulation. So addition to that, we can also say the various load which is going to act over the product. Okay, once we set up all those load cases, if we run the results, we got the results called stress plot. The stress plot says how much stress is developed over the model by this load cases and what the displacement happened in my model. And also I need to see how much life the component will sustain. So sort of fatigue analysis tells us how long my product will sustain. This component is sustain around 1800 cycle of this type of loading. Okay, I had done the all those study in plastic injection molding and solder simulation. Now I need to share those results to my customer to impress them. For that, what we can do, we can export these results as an e-drawing file. Once these results get exported to e-drawing file, we can open those results in e-drawing viewer, which is available free of cost for your customer or if any user. So in that they can virtually animate and see how the cavities get built and what's the pressure conditions and the flow conditions. They can also share their comments over our design. Okay, the final thing I need to do the documentation work. For that, what we can do, we can make use of automated report generation tool, which is available in both sort of simulation and sort of plastics. In that, we can include what are the plots we need to get documented and what are the additional details we need to provide, and we can share our own company template to generate these reports. These reports will be look like this. Sawdust plastics and a sawdust simulation will generate these reports virtually and say all the details and all the plots where we can have an in-depth history of the analysis. So documentation work also get done automatically. Okay, by sawdust solutions, we can design the plastic part and we had done the analysis over the plastic injection molding, and we can transfer all those results like residual stress to sort of simulation for stiffness calculation and life prediction. Once this testing is done, we have shared those results with our customer to impress them over our new design concept. And finally, we had documented all those activity using sort of report generation tool, where we can generate the report automatically in our own company standard. So this is an integrated solution of the sawdust for an entire plastic the component design process. We like to share one more case study, which is done by Professor Stephen Johnson from Maslow. They have their remote plastic engineering department, where they have the injection molding machines. What they done, they taken a tool cavity sensor component with PP material, with pin gate and the copper insert. What they had done study with the two type of study with the steel insert and the copper insert. So they had find out the temperature, it's around 28 to 32 degrees of the insert. When they compare these results with the Sodos simulation, what they had find out is it's a huge result. Like when they use the steel insert, they find out the temperature distribution is not uniform, and the thread deformation is happened. And if they use the copper inserts, then everything is to set to be normal. They compare these results with their practical test scenario. Like after packing stage, what's the gate freeze time has happened? It's around 5 to 6 times ideally in a practical manner. The same scenario is calculated in sawdust plastics. They had observed that at exact 6.5 seconds, the gate freezing is get started. Then they compare with the plot which are available in sawdust plastics, which pot weight versus the packing temperature. They find out at the exact 6.5 seconds, the saturation is get happened. And they also stop the pot cavity filling at each time second frame. How the sort is happen, the exact same scenario is seen to be observed in sawdust plastics. And we have one more customer called Salzer Electronics at Coimbatore. They're developing a product called S90. They're facing some issues in the pot design like sort, and they need to find out the correct gate location and correct runner size. For that, what they had done, they had tested those designs in sawdust plastics. They gone with various design iterations in design stage itself, and they had find out the correct timing or correct runner design in design stage itself using sawdust plastics. Then they gone with the production. They got a successful product at their first iteration itself. And these are the various components they are testing with the earth terminal top cover and the base cover. Let's share as our product capability. Sawdust plastics have the entire capability of testing the scenario of plastic injection molding, starting with the fill time required to fill the cavity, sort analysis, wellline analysis, ATRA finding, and multi-gate locations, gas injection molding, and we can also do insert over molding, fiber and fiber resistor analysis, and we can choose the best cooling layout and how the components get warped. The entire solution, engineering solution is available in sawdust plastics. We have also have other few solutions like for an FE analysis, for stiffness analysis, we have sawdust simulation solutions, and for CFD solutions, we have sawdust flow simulation, and injection molding solutions, we have sawdust plastic. So we can utilize those products to have an end-to-end solution over your product development. We have few of the customer references in India, starting with Salzer Electronics, Neoponics, Elcamel, Radex, Shelik, Sele, Ravi Plastics, and Trigonal Solutions, and Otter, Rashmi, and Tafei. We got these are the few customers in India, and we compare and we go through the Asian customer references. We have all renowned companies called Samsung, Canon, Panasonic, and if we go with the Asian level, we have Seiko, Thermax, Juniper. We have these are the few customer references. And once again, thank you for attending this section. If you have any questions, you can write up to us. Or if you need any, if you are facing any difficulty in injection molding, or you're expecting for any solutions over the plastic injection molding, you can directly visit us to our website, or if you need any further webinar details, you can follow us on Twitter at EGS India and EGS Sourdough. You can write up us through the below mail for any solutions you require. Once again, thank you for attending this section. Thank you.